Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving linear equations. So what makes them equations is the equal sign here. What makes them linear is that the pronumeral or letter has no power attached to it. So what we do with linear equations is we solve them. So to solve them means we're finding a value we can substitute for the pronumeral to make them true statements. Now the way that you solve them is to undo what's been done to the pronumeral in the opposite order to BIDMAS. So let's look at this equation here, 20 minus 7x equals 83. A lot of people get tripped up with these kind of questions. They don't really know what happened with the 20. Well, that 20 is a positive 20, so the only way it could have been there is if 20 was added. So positive 20 there. Now when I solve this, I need to solve in the opposite order to BIDMAS. BIDMAS tells us that we multiplied first, then added. We multiplied x, some random number, by -7, then we added 20. So it's just like in the morning you put on your socks and then your shoes, but at night you have to take off your shoes first because they were the last thing you put on. So because this was the last thing put on, the last thing done, I need to undo it first. So I'm going to subtract 20 to undo adding 20. And the rule with these linear equations, what you do to one side, you must do to the other. So I'm left with -7x equals 63. This is -7 times x. In algebra, if no operation's written, it means times. So the way I undo timesing -7 is to divide -7. They will cancel out. Once again, what you do to one side, you must do to the other. So the answer here is x equals -9. If I substitute x for -9, this becomes a true statement. There is no other number I can substitute for x to make this a true statement. So x equals -9 is the unique solution. It is the only solution to this equation. All right, we're going to follow a similar process here. So here what's happened, x was actually multiplied by -1, because you know if no number's written in front of a pronumeral, it's 1. So x was multiplied by -1, then 4 was added because it's a positive 4. Then we divided by 2. Then we multiplied the whole fraction by -1, and then we added 10. There are a lot of operations here. But once again, because the adding 10 was the last thing done, it's the first thing I must undo. So I'm going to subtract 10 from this side of the equation, and what you do to one side of the equation, you must do to the other. So I end up with -4 minus x over 2 equals 6 minus 10, which is -4. Now see, when you get in a situation like this, we can change the sign. We can make these both positive. You can do whatever you want to one side of the equation as long as you do it to the other. So I can change the sign of this side of the equation as long as I do the exact same thing to the other side. So I'm changing both sides, their sign, from negative to positive. So now I have x was times by -1, 4 was added, then divided by 2. This is now the last thing left that was done, so first thing I undo. You undo dividing 2 by timesing 2. What you do to one side of the equation, you must do to the other. So I'm left with 4 subtract x equals 8. Now, the way I undo adding 4 is, of course, to subtract 4. They cancel each other out. What you do to one side, you must do to the other. I'm left with -x equals 4. Once again, I can change the sign of one side of the equation as long as I change the sign of the other side of the equation. X equals -4 is the answer. If you substitute that for x, you get a true statement. All right, let's now look at equations with pronumerals on both sides. So when I say pronumeral on both sides, I'm talking about the letter being on the left and right-hand side of the equal signs. So when you have equations like this, first expand any brackets or remove any fractions if there are any. Then we subtract from both sides the pronumeral with the lowest coefficient. After we've got rid of brackets and fractions, we want to move the pronumeral so it's only in one spot, because we really only know how to solve equations when the x or the pronumeral is in one spot. So after it's in one spot, we can just solve as normal. So if we look at this equation here, there are no brackets or fractions to remove. We go straight to step 2. So we're going to subtract from both sides the pronumeral with the lowest coefficient. This pronumeral x has a coefficient of 3. This pronumeral x has a coefficient not of 7, negative 7. So I'm going to subtract negative 7x because negative 7 is lower than 3. You, of course, know that subtracting a negative is the same as adding. So essentially I'm adding 7x to both sides. That will get rid of it on the left-hand side. So I've got 11 equals 3x plus 7x plus 21. Now this is an easy equation to solve. Subtract 21 from both sides and then divide each side by 10. You get x equals negative 1. It's the solution because if you substitute x for negative 1 here and here, you get a true statement. All right, this is a lot more complicated here. Here we do have fractions, so I'm going to first try to get rid of those fractions. So the way I'm going to get rid of this fraction is to times by 2. Because timesing 2 and dividing 2 undo each other. What you do to one side, you must do to the other. But the thing is, when you're multiplying this side of the equation by 2, you have to multiply everything by 2. So when you multiply this fraction by 2, the 2's just cancel out. So you're just left with x plus 5. But you also need to remember, because people often forget, you've got to multiply this by 2 as well. Now, when you're multiplying a fraction by a whole number, you only multiply the top by that whole number. Notice I didn't times the 3 by 2. I also need to times the other side of the equation by 2. All right, now I'm going to get rid of this fraction here by multiplying by 3. So I'm going to multiply each side by 3. So that means I need to multiply this expression by 3. So I'll just get 3 lots of x plus 5. When I multiply this fraction by 3, the fraction just goes away. So I'm left with this. And of course, on the right-hand side, 2x times 3 is 6x. So I've removed the fractions. Now I have brackets. I must expand the brackets. 3 times x, 3 times 5, negative 2 times negative 2, negative 2 times negative x. Okay, so now we have 3x plus 2x is 5x, 15 minus 4 is 11. All right, now we're going to go to step 2, subtract from both sides pronumeral with the lowest coefficient. So this one, 5x, is clearly a lower coefficient than that. When I subtract 5x from both sides, I get 11 equals x. That is my final answer. If you are to substitute x here, here, and here for 11, you get a true statement. All right, let's now look at a worded problem. So I'm 12 years older than my brother. 6 years ago, I was 3 less than double his age. How old is each of us? So we're going to use equations to solve this. When you're solving worded problems using equations, your first step is always to define variables. So let x be one of the things you're trying to find. So I'm just going to let x be the brother's age. Now, the problem is in this question, we're asked to find two things: my brother's age and my age. So I need a variable to represent my age, but I can't use a different letter or pronumeral. See, we don't know how to solve equations that have multiple pronumerals. So I'm not going to let like y be my age. I'm going to write my age in terms of x. So if my brother's x and I'm 12 years older, my age is simply x plus 12. Notice I've used the same pronumeral to define both of the things I'm trying to find. So after we've defined our variables, we set up an equation. So 6 years ago, my age was x plus 12, which is my age now. Subtract 6. So the worded information is telling us that that was my brother's age 6 years ago, doubled, and 3 less than that. We now have an equation we know how to solve. Let's just tidy it up a bit. So x plus 12 minus 6, just collect like terms. And we know that the first step in solving an equation with pronumerals on both sides is expand any brackets or remove any fractions. 2 times x, 2 times negative 6. Of course, negative 12 subtract 3 is just negative 15. All right, now I'm going to subtract the pronumeral with lowest coefficient. It's this one, its coefficient's 1. So if I subtract x from this side, they cancel out. What you do to one side, you must do to the other. So I'm left with 6 equals 2x minus x is x minus 15. Simply add 15 to both sides, you get 21 equals x. That means my brother's age is 21, so that means my age is 33. 6 years ago, I would have been 27, which is 3 less than double 15, which would have been my brother's age. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.